Hey everybody, just wanted to check in with you a little bit. It's time for, and week 2 is ending, and so I wanted to put up a blog where we kind of talked a little bit about what happened this week, some of the observations. A couple of people have made comments. They've either sent me emails or they even posted in the open forum, and so I wanted to sort of address some of the comments I was hearing, some of the questions people had. So we'll go through that a little bit. I suggest you read the reading that's below. Kind of gives a lot of information, a couple of good sources in there. People sort of expressed surprise that this challenge wasn't something that they were working on in their community or a real life sort of challenge. I kind of just make this distinction between real world and real life. Real life is that it's actually happening out there. The Wetland Watchers is a good example of that. And that in real world challenges or projects, they're hypothetical, but they feel real and they feel authentic, and that works just as well as some of the real life challenges or real life projects can. So a lot of you are wondering, how am I going to do this? How am I going to find something like Wetland Watchers in my community? And the point is, you don't really have to. So there's some more on that in the video from this week. You can find that in late in the module 3, I believe, in week 2. So below you'll also see a link from TED. I don't know if you know what TED is. TED is a small nonprofit that's sort of devoted to giving innovators and creative people and big names like Al Gore down to individuals who run a small business in the middle of Heartland, America, a forum to speak. And basically they share their ideas. Sort of an open soapbox. They only have 18 minutes to do it, or that's the maximum amount of time they have to do it. And there was a really excellent presentation given by Dan Meyer, who's a math teacher. And I thought that Dan's presentation about how students learn math now and how they should be learning math really mapped well into what we're trying to talk about in this course. So you can scroll down and find the link there to the TED conference, as it's called, the Technology, Entertainment, and Design Conference, TED. You can find his video. It's really entertaining. It's pretty funny, but it's also really enlightening. And one thing I actually really liked about it is that it provides you sort of a model for how you make change to sort of simple math problems, and that change isn't all that different for science courses either. The other thing I wanted to really kind of go over was talking about where are we in the challenge and why have we done what we've done so far, and then also talk about some assessment items. Really, if you've kind of figured it out, the first part of the project is just to find out what you know as a learner. Now, obviously a lot of you know what's going on here. The science isn't all that much of a mystery to you, but imagine if your 8th or 9th grade students were sort of engaged with this. How might they be reacting to the things that we're doing in the activity? How would they look at the phenomena of those things dropping and give explanations for it? And then did you see how we sort of elicited their ideas and their engagement? And then we talked about, well, what do you know about how things fall? And there was no judgment about that list. And then it was, okay, well, here's this device, and we've got to make it fall slower and more predictably. What do you think would affect that? And now you've essentially engaged them in problem identification, and you've engaged them into variable isolation, variable control, variable identification. And then, of course, in the last assignment 6, you were to put together a plan for experimenting on that particular variable. So you're sort of focusing and narrowing those students down. So as you can see, the PBIL has there's a good amount of teacher control here. I mean, we're really sort of focusing and scaffolding and sort of pulling the strings as to where students go. It's not some open-ended free assignment. And it's really going to target some very specific learning goals that we have about understanding some things about force and motion, and understanding things about how scientists do their work collaboratively, and how scientists design experiments to isolate a variable and determine the effect of a variable. Those are all very important things for students to learn. Most of your state standards probably include those kinds of ideas or something similar to it. So it's not some big open-ended assignment. It's not totally in the hands of the students. But it feels like it's in the hands of the students, and it feels like that to them. They're making decisions. When they created the variable list, they inevitably were going to come up with paper clips and wing length. There's no doubt that would happen, and that's where you wanted to head as a teacher anyway, because you really want, those two things have a lot to do with the science that's governing how something falls, and so that's really important. Next week, what we'll do is we'll be getting into more content-oriented items where we can sort of understand or assess their understanding and then their growth of that understanding. And it will include actually some very traditional types of things like lectures and homework. So fear not, those traditionalists out there, not all that stuff is going to be thrown out. In fact, it's really, really important part of the process. But for now, we're just trying to engage these students and figure out where they are and what they understand and what they know so that we can tailor the sort of second half of the challenge to meet them where they need to be met. The other thing I want to talk a little bit about is assessment, and I know there was a short video about sort of individual accountability versus group accountability, and that's fine. But you know, one thing to do is to start thinking. You can think about PBIL working differently than sort of traditional approach. Well, that goes the same for the assessment. It doesn't, you know, you haven't seen examples of this, but I could give you a couple of homework sheets or maybe some worksheets or something like that that talked about things falling, and as long as those sheets didn't reveal the science content that I want you to sort of come to on your own or come to through a different experience, I can still hand out, they could have a practice sheet for designing experiments where they read a short scenario of 3 or 4 experiments that someone would like to design, and they could take that experiment plan sheet and plan out experiments to practice it as they turn in their version for this particular challenge. That's homework, that's assessment, those are gradable items. You can, basically you spend a lot of time sort of when they're identifying variables or they're giving their explanations on their predict, observe, explain sheets. Maybe those things aren't very valid. Maybe they're not correct. I wouldn't want to grade somebody on how much they know about the science governing this when they haven't really had a chance to learn it. But I can grade them for participation and effort and time and sincerity. And that's okay. That's all part of it. So, you know, and those students can work on those things individually and then get back together with their groups and sort of come up with group decisions. But we know that they went home or they spent time in class perhaps doing this on their own and giving their own answers. So that individual accountability can be there. The one thing I would like to point out, and I'd point out down here further in the blog, is the idea about grading. How do we grade people? Well, this is a much bigger topic of conversation, and we will get to it hopefully a little bit later in the course. But read what I've written here and see, you know, you might have strong feelings one way or another. I know that there are restrictions about how you grade and what you grade and the way you do it and when you report it that are, you know, vary by the communities in which you teach. And so I don't pretend to think that what I've proposed here will work everywhere. But the idea is that you can take the idea down below here and convert it to work in your system in most cases. So I don't think that it's straight away. It may not fit right in, but there are adaptations. But read it, consider it, see what you think. Really, the idea is to get at watching students, sort of having students demonstrate their proficiency with something, whether it's content knowledge or skill, and then charting that over time and realizing that early on in a unit or a process, their skills should be pretty low, or they may be low, or their content understanding may be low, but that as time goes on, it should develop and improve. And if it doesn't, well, then, you know, some of that might be on the teacher, but some of that might be on the student as well. But then at least you have some way to explain to parents or maybe your administrators or other teachers justifying the number or the letter grade that you put in the box, because you're really looking at proficiencies rather than did they accrue all the points that they could possibly accrue, equating things that maybe aren't of equal value. So just something to consider. Have a good week 3. I'll send out an announcement next week talking about some things in week 3, similar to the things we've been talking about here, and we'll continue to move through. If you have any questions, of course, you can leave comments here. You can leave comments in the open forum, or you can email the instructor at epdnpbil@gatech.edu. Thanks.